Okay, helium is the most abundant isotope of helium. Okay, helium-4. Its nucleus mass, you see, all this while we are just talking about only the nucleus. Yeah, we don't look at the atom. Okay, one thing to re-emphasize for you is we don't look at the atom. Yeah, we just take the nucleus mass. Yeah, mass of nucleus only. So the electron not included. Okay, the mass of electron not included because we don't take the whole atom. We just take the nucleus only. We just take the nucleus mass. Right? Nucleus means what? Only the proton and neutron. Okay, this one is the proton and neutron only. Yeah, at the nucleus. Only the proton and neutron. We don't have electron there. Yeah, electron is the orbit, in the orbit. Okay, so the nucleus mass is this one in kilogram. Okay, good. Okay, we have the mass in kilogram. This is actually called the mass of the helium nucleus. Okay, in kilogram, this one is SI unit. Calculate the mass defect. Okay, to find the mass defect, you must know, first of all, you must know how many proton, how many neutron. Okay, let us write it down first. Write the equation first. So from there we know it has 2 proton plus 2 neutron. 2 proton plus 2 neutron, because it's take the mass number minus the proton number, we get 2 neutron. So 2 proton plus 2 neutron, we get the helium nucleus. Okay, so to find the mass defect, we just take the nucleons minus the nucleus. Okay, this is the nucleons minus this is the nucleons, this is the nucleus. We know that nucleons always has more mass than nucleus. Okay, so we always take the nucleons minus the nucleus, the big minus the small. Okay, so let's calculate. Yeah, just use the formula and at the top here. So you have 2 proton and 2 neutron. So 2 mass of proton. Alright, so since we only have the mass in atomic mass unit, hold on a second. Yeah, let me find out the mass in kilogram. Alright, please look at below here. I have found out the list of constant. Okay, if you look at our list of constant, you are provided the mass of electron. Okay, we have the mass of electron, we have the mass of neutron, we have the mass of proton, and we have mass of deuterium. What is deuteron? Deuteron actually is hydrogen 2. Actually is hydrogen 2. Okay, deuteron, because we have three. We have three kind of hydrogen. You know that hydrogen has 3 kind of isotope. We have strontium, we have proton, we have the deuteron, we have the tritium. So this one actually is the proton, just a proton. Okay, this one is deuterium, or is called proton. Yeah, proton. Wait, hold on a second. Okay, I want you to look at this. Yeah, I want you to look at this. I have checked the Wikipedia. Hydrogen has 3 kind of isotope. Yeah, hydrogen 1, hydrogen 2, hydrogen 3. So the hydrogen 1 is called the protium, or just a proton itself. Yeah, it's called protium. Pro means just 1. Deu means 2. Deuterium 2. Okay, the mass number is 2. Pro means just 1 mass number. Tritium means you have 3 mass number. Tritium. So hydrogen 1 is protium, the hydrogen 2 is deuterium, hydrogen 3 is tritium. Okay, let's look back. So this one is has 2 names. It can either call proton or call protium. Okay, this one can be called deuteron. Okay, how to spell deuteron, or called deuterium. Yeah, this one is called tritium. I haven't heard about triton. Triton, huh? No, I haven't heard about Triton. Triton is means something else, yeah. It's a mythological creature, Triton. Okay. I heard it's tritium, yeah, tritium. I wonder this is Triton or what, yeah. So okay, tritium. So we have proton to protium, isn't it? Protium, yes. Deuteron or deuterium. So this deuteron is this one, hydrogen 2. Okay, the hydrogen 2. So what is the difference between all these three? They are all, we call it isotopes. Yeah, they are all isotopes. Isotopes of hydrogen. They are all hydrogen. You understand? They are all hydrogen. But the hydrogen one is actually just proton. You understand? This one is you see the proton number is 1 and the mass number also 1, means the mass number 1 is the proton itself. It's only the proton. So this is I can say this is the proton. This is actually proton. You know, this hydrogen is only the proton. The proton. That's why we call it proton or protium. Deuteron, it has at least 1 proton, 1 neutron. Understand? 1 proton, 1 neutron. For tritium, it has 1 proton and 2 neutron. 1 proton and 2 neutron. Okay. And this hydrogen is actually only proton. It is proton. It is proton. Okay. Deuterium and tritium. Okay, let's not waste our time. Just to let you know, yeah. So this deuteron also given the mass in the list of constant. So when exam, this list of constant will be provided. Okay, this is called the list of constants. So you don't have to remember all the values here because it will be provided in the exam. These are the list of constants. Remember to check the mass of neutron, mass of proton. Over here, we have either in kilogram or the atomic mass unit. So you don't need to change like from atomic mass unit to kilogram because it's already provided. Yeah, I know you can change from atomic mass unit to kilogram. You just multiply 1.66 exponent negative 27. But don't bother the trouble. Just use the value. If you want kilogram, just use kilogram. If you want atomic mass unit, just use atomic mass unit. Okay, just use at your convenience. Yeah, just use which one you want. Okay. So right now, which one I'm going to use? Kilogram or atomic mass unit? So it all depends on the question. So if you look at these questions, it gives the nucleus mass in kilogram. So when you want to substitute the mass of proton here, make sure you must have the same unit as the mass of helium. Mass of helium is given in kilogram. Okay, this one is in kilogram. So this mass of proton and neutron must all in kilogram. You understand or not? Must have the homogeneous unit. Same unit. So the mass of proton, don't use the atomic mass unit lah. Don't use the U. Understand? Don't use the U. Use the kilogram. Okay. So use the kilogram. And I also know in the calculator, in the calculator actually also have the mass of proton value. But always stick to the value given in the list of constant. Okay, always stick to the value given in the list of constant, because in the calculator the value given for mass of proton and neutron too accurate. This one, the value provided in the list of constant already rounded up, and our answer scheme all use the value given in the list of constant. So the answer scheme will tally with the masses in the list of constant. It will not tally with the mass given in the calculator. Understand or not? So your mass of proton and neutron must always take from the list of constant provided in your exam. Don't use the value of mass of proton or neutron in the calculator. Don't use the one in the calculator. Okay, use the one given in the list of constant. Okay, because the answer scheme follow the value of mass in the list of constant. Okay, so just choose the value in the list of constant. Don't use the value given in the calculator. Okay, so here, since here the helium given in the kilogram, so the mass of proton and neutron also must be kilogram. Must be in kilogram. So we take these two lah. So first of all is the proton. Mass of proton is this one. Okay, 1.672. Just write it down. 1.672 exponent. What is the value? Exponent negative 27. Negative 27. And then plus the mass of neutron. Neutron we have 1.674 is bigger mass. Neutron is a bigger mass than proton. 1.674 also negative 27. Okay, 1.674 exponent negative 27. And then now I want to minus the mass of helium. Mass of helium is 6.6447 exponent negative 27. Okay, for 1 second. So now I want to calculate the value. Let's calculate the value. Okay, so the answer is let me check. The answer is 4.73 exponent negative 29 kilogram. I got the unit in kilogram. Okay, so the answer is you see, a bit different from the answer given, 4.822, because the if I know the answer scheme, he used this this question does not use the value given in the list of constant. Yeah, he used a much more complex value for mass of proton and mass of neutron. So actually this one is the correct answer. This one should be the correct answer. This one is not so accurate. Okay, this one is not so this one is the is the correct answer based on the list of constant. This one is not the answer based on the list of constant. Yeah, it's not based on list of constant. Use the one that based on the list of constant. Okay, don't use the one that do not based on the list of constant. Okay, don't use this one. Okay, use this value that based on list of constant given. Okay. Okay, so yeah, you see there'll be so much difference. You see, I already show you there'll be a lot of difference if you don't use the value based on list of constant. So if you use your own value, in the calculator, you get this value. Okay, so it's not the same as the answer scheme value. So be careful, yeah. Now let's look at the second question. What's the binding energy of the nucleus in joules and electron volts? Okay, so he wants the unit. He wants the answer in 2 units, joule and electron volt. So now we use the formula E equal to mc square, equal to delta mc square. This one you can use the formula E equal to mc square because all in SI unit. We already got the unit in kilogram. Understand or not? Unit in kilogram. We already got in kilogram. So we can safely substitute into this formula because this formula also requires the mass in kilogram, and the energy we get surely in joule. The energy we get surely in joule. Understand? So now let's substitute our delta M, which is 4.73 exponent negative 29 kilogram. This is in kilogram. Multiplied by the speed of light. Okay, speed of light is 3 exponent 8. 3 exponent 8. Okay, and then square. Then let's calculate. Yeah, let's calculate and see. Okay, so you see, I get the answer in 4.257. 4.257 exponent negative 12 joule. So in SI unit, I got the answer in, this is the SI unit. So is the answer correct? You see, that's the difference. However, my answer will be safer because it is based on the list of constant value. Yeah, I use the mass of proton and mass of neutron based on the list of constant provided in the exam. So I get this answer should be correct. Okay, should be correct. This one not so correct because it does not based on the not so correct. But sometimes we also accept. Yeah, we just accept. Yeah, just to help the students. Encourage you not to use other values other than the list of constant. Always use the mass of proton and mass of neutron from the list of constant only. Only use the mass of proton and mass of neutron from the list of constant only. Then your answer will be closer to the answer in our answer scheme. Okay, in our answer scheme. If you use other value, you see, if you use other value of mass of proton and neutron, you get much different answer. This chapter very sensitive. A small changes in the value. Will result a big difference in the final answer. Let me show you. Let me show you the real answer scheme. The answer scheme for this answer. Yeah, and you can check with the list of constant. Is it the same? Okay, let me show you. Yeah, let me show you. You see here. Do you see the mass of proton? Do you see the mass of proton given? He used 1.672078. So accurate. This is not the list of constant. This is not from the list of constant. The mass of proton, mass of neutron also use 1.674382 some more. So this is not the list. This is not from the list of constant. Our list of constant only have 3 decimal place. If you look at here, our list of constant only have 3 decimal place. 672 just now. Okay. Your mass of proton, you use 672,078. Wow. Mine is just 672. The list of constant just this 672. Use the one 672. Don't use the one with 672,078. Okay. The neutron also is only 674. But your mass of neutron here is 674,382. My gosh. Yeah. No wonder your answer is so much different. Yeah, you get 4.822. You get 4.822. I got only 4.73. Do you see the difference? You got 4.822 because you're not using the list of constant value. You use other values. You use 4.822. If you get this value, it's different from the exam answer scheme. Exam answer scheme, use the list of constant value, you get 4.73. Yeah, this one is better answer lah. Which is based on which will be reflected in our exam answer scheme. Okay. So you see, a little bit difference only. In the decimal place. Will result in a big difference. In the final answer. A big difference in the final answer. Why like that? Because this one is a very, very small value. Because this is exponent negative 29 kilogram. You know that? Exponent negative 29 means in front how many zero is that? Yeah? That means this is exponent negative 29. That means in front there got how many zero? Yeah, got how many zero in front? Got how many zero in front? So this is a 0.0. You understand? So this is a very, very small value. No wonder if you use not the list of constant value, this very, very small value will have very big difference. Actually, it's not a big difference because this is exponent negative 29 value. That's why it becomes like looks like very big, but actually it's very small changes because it's a very small value. You understand that? You understand that? So always use the list of constant value. Use the 1672 and use 674. Don't use the 672,078, 674,382. Don't use this value. Okay? Use list of constant value. Use this value. Use only this. Okay? Use only this. Okay, which is provided in the exam. Exam provided. This exam provide. Exam provided. Understand? Exam provided. Use only this. Then you get the correct answer lah. Correct answer. Okay. So now we got this. Okay. Okay. So we got already the answer in just now energy in joule. So how about the mega electron? We want the electron volt, not mega electron volt. So how to convert to electron volt? How to convert to electron volt from joule to electron volt? From joule to electron volt, we divide electron, because electron volt to joule we multiply. Now from joule to electron volt we divide by electron charge. Yeah. So what you do is you divide by electron charge. So 4.2. So 257 exponent negative 12. I divide by electron charge. Electron charge is 1.6 exponent negative 19. So what do I get? Let me check the answer. Yeah, 4.257 exponent negative 12 and divide by 1.6 exponent negative 19. Okay, so the answer is 2.661 exponent 367 exponent 7 electron volt. If you want to divide, if you want to get mega electron volt, you divide mega some more. Divide mega exponent 6. Divide mega. Yeah, this is how it is. Yeah, I see. From electron volt go to mega, you divide mega some more. Divide mega. Divide mega. So I divide mega. So divide 1 exponent 6. So I get 26.61 at mega electron volt. That's the answer. Okay, is that correct? Wow, you see that the difference is the difference there. Mine is 26.61, but you get 27.1. So don't use this one. Use mine, because mine is based on list of constant value. Okay, mine used on list of constant value. So you have 2 units, joule and mega electron volt. Okay, understand? So my conclusion is just use the list of constant value, then and maintain as many decimal places as possible. Then you get the correct answer. Okay, see you in the next video.